Finally, we have the neural responses in the auditory cortex. So there are two basic types of eighth cranial nerve neurons: low spontaneous rate or high threshold, and high spontaneous rate or low threshold fibers. And neurons are all or none devices. Every unit response is equal to the next in intensity and duration. The only way that neurons can provide a differential response is in the rate of the firing. So when the eighth cranial nerve fibers respond to tonal stimulation, there's an initial burst of strong activity, followed by a decline to a plateau of discharge over the duration of the tone. And when the tone is terminated, the response fire drops below baseline levels, rising up to baseline noise levels after a recovery. So humans can discriminate changes in frequency of a signal of about 2%, and figure 510 shows a tuning curve for a single unit recording. A tuning curve is basically a composite of the responses of a single fiber at a frequency presentation. So if you look at this, the fibers have, every fiber, just like each outer hair cell, an inner hair cell has a specific frequency that it translates. Same thing with the fibers. So you can see that fibers that are most sensitive in this figure, let's say the one at 10,000 hertz, if a sound comes in at 10,000 hertz, and this is a 10,000 hertz nerve fiber, then the sound doesn't have to be of that great intensity for it to fire. Now, the further you move away from 10,000 hertz, or the best frequency of that nerve fiber, the louder or the greater the intensity the sound needs to be for the nerve fiber to fire. So just like our outer hair cells and the basilar membrane and the inner hair cells have frequencies that they're specific to, same thing with the nerve fibers. So we have neural specificity headed up to our auditory cortex. Now, as we move up further and further in the auditory pathway, what we have the firing that's sent up to the afferent nerve fibers. Remember, afferent nerve fibers send messages up to the brain. And we have processing and reprocessing and processing and reprocessing of sound. So the messages get sent up and they get sent across, and then they get sent up further and across and further and across, and there's this intrinsic redundancy of sound processing all the way up to the auditory cortex. And the intrinsic redundancy, or the processing and sharing and reprocessing of sounds from both the right and left sides of the brain, are what help us separate out the signal from noise. So temporal, remember time, and frequency arrayed information is passed progressively to higher centers of the brain for further extraction of the information. The superior olivary complex is the primary source for localization. The medial geniculate body is a relay of the thalamus, and it just goes up and up and up.